Hello friends, let us study current flowing through each branch of your parallel resonant circuit. So as shown in figure, there are resistance and inductor connected in parallel with capacitor, and the entire combination is in parallel with the supply voltage. So we can say the upper branch is nothing but branch 1 and the lower branch is nothing but branch 2. The current flowing through upper branch is IL. As inductor is connected in series with resistance, current will be lagging. So this is shown in this phasor diagram. Current is lagging by angle phi L. As resistance is present, this phi L is less than 90 degrees. And in branch 2 only capacitor is connected. So current is leading the applied voltage by 90 degrees. Angle phi L can be calculated from impedance triangle as shown in figure B. This impedance triangle is with respect to RL series circuit. That is, we have a resistance in series with inductor. So this is RL series circuit in parallel with capacitor. So we can draw a impedance triangle like this. Here this is resultant impedance, that is Z, and resistance connected in series with inductor. So inductive reactance is XL is shown as vertical line and resistance is shown as horizontal line. The angle is phi L. Now from this diagram we can calculate phi L as tan inverse of XL by R. So like this, phi L we can write down tan inverse of XL by R. Now for the capacitor circuit, the capacitor is only connected here, there is no resistance. So as such, IC will be leading the applied voltage by 90 degrees. The current in the capacitor IC will be given by V divided by capacitive reactance. Now capacitive reactance formula is known to us, that is 1 upon 2 pi Fc. Therefore IC will be V divided by capacitive reactance Xc. Resultant phasor diagram at resonance is drawn over here, somewhat faint. This is current in the capacitor, this is current in the inductor, may be indicated by IL. Resultant of this IC and IL can be calculated with the help of the law of parallelogram. So we can have I is equal to IL plus IC in vector directions. So at resonance we know power factor, that is cos phi, is equal to 1. Therefore V and I are in phase and hence phi angle is equal to 0. So this is shown over here, this is V and this is I. So V and I are in phase with each other at resonance. Therefore cos phi, that is angle between V and I, will be 0 and cos of 0 will be 1. So cos of phi will be 1 here. Therefore at resonance condition we have to assume I is equal to, this is I current and this is phi L angle. So this I must be equal to IL cos of phi L. So at resonance we can write down I is equal to IL cos of phi L. Okay, so this I current must be equal to IL cos of phi L. How this came? This is phi L. So if I calculate cos of this phi L, this will be this I current. So I must be equal to IL cos of phi L. And as at resonance current is equal to 0, so this vertical portion, that is IL sin of phi L, must be equal to this vertical current IC. So these are equal and opposite to each other at resonance. So we can write down IL sin of phi L is equal to sin IC. Okay, so at resonance this thing happens. The resultant current I is equal to IL cos of phi L and IL sin of phi L is equal to IC.